Welcome to G Fun Facts Online. Tonight, we're looking up, way up, into the velvet black of the night sky, to a place where the cosmos puts on its most spectacular light show. We're talking about the Aurora Borealis, the northern lights. For centuries, these ethereal curtains of light were the stuff of myth and legend, the spirits of ancestors, the bridge to the gods, omens of war. Today, science has pulled back the curtain, but the magic, the sheer awe of witnessing it, remains. In the next 20 minutes, we're going on a journey. From the fiery heart of our sun, across 150 million kilometers of space, and into our own atmosphere to understand the science, find out where and when you can see it, and even learn how to capture it on camera. Let's unravel the magic of the northern lights. The story begins with the sun. It's a colossal nuclear furnace, constantly blasting a stream of charged particles, electrons and protons, into space. This is the solar wind, and it travels at incredible speeds, sometimes over 70 million kilometers per hour. As this solar wind approaches Earth, it meets our planet's first line of defense, the magnetosphere. This is a protective magnetic shield generated by the molten iron core deep within our planet. It deflects most of the solar wind. But this shield isn't perfect. Near the north and south poles, the magnetic field lines create funnels. And here, some of those charged solar particles get trapped. They are channeled down towards Earth and slam into our upper atmosphere at altitudes between 80 and 1,000 kilometers. This is where the magic happens. These solar particles collide with atoms and molecules of gas in our atmosphere, mostly oxygen and nitrogen. The collisions excite these atoms, giving them excess energy. To return to their normal state, they have to release that energy. They do so in the form of light. What we see as the aurora is the cumulative glow of countless trillions of these tiny light releases, or photons. The beautiful dancing shapes we see, the curtains, arcs, and bands, are formed as the particles follow the Earth's magnetic field lines. The ever-changing flow of the solar wind makes the aurora swirl and dance across the sky. The intensity of this celestial ballet isn't constant. It's heavily influenced by the sun's 11-year cycle. During periods of high activity, called the solar maximum, the sun throws out more powerful solar storms, like solar flares and coronal mass ejections. These events supercharge the aurora, making the displays brighter, more dynamic, and visible from much further south than usual. We are currently in a solar maximum, which is why you might have seen news about aurora sightings in unexpected places. But even during the solar minimum, the lights don't go out. There's still a steady stream of solar wind, ensuring the show goes on, especially in the far north. One of the most captivating aspects of the aurora is its color. The most common color you'll see is a brilliant green. This is produced by excited oxygen atoms colliding with solar particles at altitudes of about 100 to 300 kilometers. A rarer sight is a deep, haunting red. This is also caused by oxygen, but at much higher altitudes, above 200 kilometers. Here, the atmosphere is thinner, giving the oxygen atoms more time to emit their red light. These blood auroras are usually only seen during periods of intense solar activity. If you look at the lower edges of the aurora, sometimes as low as 100 kilometers, you might see a pink or dark red glow. This is caused by excited nitrogen molecules. The same nitrogen molecules, at even lower altitudes, can produce shades of blue and purple. These colors are often at the very edge of what the human eye can see, but a camera can capture them beautifully. So you want to see this for yourself. Where do you go and when? Your target is a donut-shaped region around the magnetic North Pole called the auroral oval. For the best chance of a sighting, you need to be inside or very close to it. This oval covers the northern parts of several countries. In Norway, places like Tromsø, Alta, and the remote Svalbard archipelago are prime destinations. In Sweden, head to Swedish Lapland. Abisko National Park is famous for its blue hole. a patch of sky that often stays clear even when it's cloudy elsewhere. In Finland, you can see the lights up to 200 nights a year in places like Rovaniemi or Ivalo. You can even stay in a glass igloo and watch the sky from your bed. Iceland is another fantastic option, as the entire country lies within the oval, offering dramatic volcanic landscapes as a backdrop. In North America, head to Canada's Northern Territories. Yellowknife is known as one of the best spots in the world. Or, for those in the US, Fairbanks, Alaska is your best bet without a passport. It sits directly under the oval and offers a 90% chance of a sighting if you stay for 3 nights. The aurora is actually present all year round, but you can only see it when the sky is dark. This means the prime viewing season is from late August to mid-April. The periods around the spring and autumn equinoxes, in March and September, are often best. This is due to the tilt of Earth's axis, which creates a better connection for the solar wind to interact with our magnetosphere, often resulting in more intense displays. The middle of winter, from November to February, offers the longest, darkest nights, maximizing your opportunity. The best time of night is typically between 9 p.m. and 3 a.m. local time. And remember 3 essential conditions: darkness, clear skies, and patience. Get away from city lights. Check the weather forecast for clouds. And be prepared to wait. Before we understood the science, people created incredible stories to explain the lights. The Vikings believed the aurora was the Bifrost Bridge, a shimmering path for fallen warriors to reach Valhalla. Or they saw it as the reflections from the shields of the Valkyries as they rode across the sky. For the Inuit of Greenland and North America, the lights were often the spirits of their ancestors playing a game with a walrus skull. The Cree people saw them as the spirits of their departed loved ones trying to communicate. In Finland, a charming myth tells of the Ravanchelit, or fire fox. The story goes that a magical fox ran across the snow, and its tail brushed against the mountains, sending sparks into the sky. In medieval Europe, a red aurora was often a terrifying omen of war or plague. But in Japan, it's a sign of good fortune, with a popular belief that a child conceived under the northern lights will be blessed with luck and intellect. Ready to plan your own aurora hunt? Let's talk practicalities. If you want to photograph the lights, you need a camera with manual mode, a wide-angle lens, and a sturdy tripod. Cold drains batteries, so bring extras and keep them warm. Here are some beginner settings to start with. Set your mode to manual. Open your aperture to its widest setting, like f/2.8, and start with a shutter speed of 15 to 20 seconds for a slow-moving aurora. For a fast-dancing display, shorten that to 5 to 10 seconds to capture the details. Set your ISO between 1600 and 3200. Focus manually on a distant star. Even modern smartphones can take decent shots. Just use a tripod and a long exposure app, or your phone's night mode. Equally important is staying warm. You'll be standing outside in the cold for hours. The key is layering. Start with a moisture-wicking base layer, like merino wool. Avoid cotton. Add an insulating mid-layer, like a fleece or wool sweater, and top it off with a waterproof and windproof outer jacket and pants. Don't forget an insulated hat, warm wool socks, and waterproof winter boots. A great tip is to use 2 pairs of gloves, a thin, touchscreen-compatible pair for your camera, with thick, insulated mittens to wear over them. Before you head out each night, check 2 forecasts: the weather for clear skies and the aurora forecast. Websites like NOAA's Space Weather Prediction Center use the KP index, a scale from 0 to 9. A KP of 4 or higher means a good chance of a great show. And finally, be patient. This is a natural phenomenon. Plan for at least 3 to 5 nights to increase your odds. To stand beneath a sky ablaze with the northern lights is to witness one of nature's most profound spectacles. It's a humbling reminder of the powerful forces that connect our planet to the cosmos. Whether you're drawn by the science, the myths, or the sheer beauty, It's an experience that will stay with you long after the lights have faded from the sky.